So a movie theater runs its films continuously. One movie runs for 90 minutes and a second runs for 110. Both begin at 3:30 p.m. and we want to find out when they will begin again at the same time. So what we need to do here is find out how long it will take to get to the next parallel showing, as it were. That is, we need a total runtime between those two that matches up, where they're always going to be the same. So after 2, it's 180, 270, and so on for the 90-minute one, and the other would be 220, 330, and so on. Basically, even though it doesn't tell us, what we need is going to be the LCM of 90 and 110 with an extra bit of interpretation thrown on there at the end. Where if we want to get that, the first thing we need is our prime factorization, where for 90, the way I would split that up is as 2 times 45, then pull out a 5, so you'd have 5 times 9, and then you're basically done. You would have 2 times 3 squared times 5. And then for 110, I don't really like that 110. I'd split that up as a 2 times 55, then 55 is 5 and 11, so that's not that bad either. You'd have 110 is equal to 2 times 5 times 11. And then for our next step, we need to identify the largest power of every term in both of these factorizations. Actually, in each separately, I want to be a little more specific about that, where there's only one 11 that appears here. So we're going to take the 11. We have the same amount of 5s. It doesn't matter which one I pick. I'll take this one. We have only the 3s up here, so I'll take both of them here. And then we have whichever 2 we want, because there's only one each. So I'll take that one just to not make it look like I'm taking everything from 90. But we're going to see here that because these don't really share that many factors, yep, I did with the 5, be careful. But because these don't have as many factors as we did in that last case, the least common multiple isn't going to be very small. But here, if we need that LCM, which is what we want, the least common multiple of these two, and I'm being brief with my notation here, but you'd get that by multiplying 2 times 3 squared. Okay, that's not so bad so far. 2 times 9 is 18. Times 5, well, 18 times 5 is 90, so we're still not doing too bad, but then it's 90 times 11, so what we'd end up with is 990. That is to say, it will take 990 minutes for these to match up again, where if we're going 990 minutes after 3:30, oh boy. Well, that's going to be more than 12 hours. We're going to have to assume that they're running really continuously around the clock forever, that it will happen again at 8 a.m. the next day. So it'll be a little while. But that's what we have here for 5.1, looking at these things with factorizations, multiples, and divisors. The next thing we're going to look at will come next week. We're going to be moving further into Chapter 5 to talk about the numbers that we can build off of, the natural numbers, as it were, the integers, and the rational numbers. And that's where we'll be picking up then. I'll see you there.